So in this series, we'll be looking at vertical asymptotes. In the other one, we treated horizontal asymptotes, okay? So horizontal asymptotes is like a limit when s or t or the variable in question approaches infinity, okay? Now in this one, we're asked to determine the vertical asymptote. Vertical asymptote is nothing but the point at which the function is not defined. So how do I find the point at which the function is not defined? The first thing I'm going to do is this. Now from the first question, what I have is f of x is equal to s squared plus 2x minus 8 over x squared minus 4. So the first thing I'm going to do is that I will try to see if the numerator is factorizable and if the denominator is factorizable. Let me check if there are things that can cancel out in up and down. Okay, I'll check to know if there is anything that can cancel out in up and down. Okay, so what I'm going to do now is this. I'll factorize this. This is x squared plus 2x minus 8. So I believe you guys know how to punch or solve quadratic with the calculator. Okay, so our a here is 1, our b here is 2, our c is minus 8. Okay, now for the numerator, we want to punch for the numerator. I go to mode, I go to equation, option 5, I go to 3, that is for quadratic. My a is 1, my b is 2, my c is minus 8. So my x1 here is 2 and my s2 is minus 4. So this is like having x minus 2 and this one is like having x plus 4. Remember, x minus 2, if you equate it to 0, you have s is 2. S plus 4 is equal. If you equate it to 0, you get that s is minus 4. So if I factorize this, what I'm going to have will be x minus 2 and x plus 4. Now again, I will check if this one is factorizable. So this is a sums of two squares. S squared minus 4 will give us something like x minus 2 and x plus 2. You can still punch it. This is x squared minus 4. So this is like here my a is 1, my b is the coefficient of x. There is no x here, 0. My c is a minus 4. So you can still punch it there. My a is 1, my b is 0, my c is minus 4. So if you go, you have that your x1 is 2 and your x2 is minus 2. So if you bring this one inside, you have x plus s minus 2. If you bring this one inside, you have x plus 2. So that's why this s minus s plus 2. So at this point, this can easily eliminate this. So my f of s now has reduced to x plus 4 over what? X plus 2. Now for this function to be defined, we know that for every fraction to be defined, the denominator of the fraction must not be 0. Like if I have 1 over 0 now, this will give me math error. For instance now, let's assume I press anything over 0. Let's say 1 divided by 0. You see math error. 9 divided by 0. You see math error. So for this function to be defined, this thing that is under cannot be 0. Okay? Remember that I'm looking for vertical asymptotes. So the vertical asymptote now will make this denominator to be 0. You know, for this function to be defined, the denominator must not be 0. Whenever the denominator is 0, I will get math error. So vertical asymptote is that thing that will make this thing to be given math error. Okay? So for this thing now, I will now have that s plus 2 is equal to what? 0. I want a situation whereby this thing will be giving me math error or undefined. So vertical asymptote is nothing but the points that make a function to be undefined in such a way that when you put it in the calculator, you get math error. So I want the denominator of this thing to be 0. Because I know that when the denominator is 0, it will be what? Undefined. So that value that will make the denominator to be undefined is what we call vertical asymptote. So if I make a Soros formula now, my s will now be equal to what? Minus 2. So the vertical asymptote for this function is minus 2, which is option C. Now look at question number 2. Find all the vertical asymptotes for the graph. So here f of x is equal to x squared over 4 minus x squared. So if you look at this very well, remember I said that the first thing you do is that you factor the numerator and factor the denominator. So the numerator is just x squared. There is nothing to factor. So the denominator is 4 minus x squared. So you just work on the denominator because you can't factor out anything in the numerator. Remember the first one we did, we have a quadratic function up, we have a quadratic function, then I was like, let's factor this one, then check if there are things that can cancel off. But in this one, what we have is just s squared over 4 minus s squared. So there is nothing to cancel off. So I'm looking for the value of s such that the denominator of this thing will be what? 0. I know that when 0 is down, I will be getting math error. Don't forget that vertical asymptote is the function that makes, is the values that make the function to be giving math error. So let the denominator be 0, because I know that if the denominator is 0, I'll be getting math error. So here I'm trying to find the possible values of x at this point now. So I will now have 4, this is 4 minus s squared is equal to 0. So this will now be 4 is equal to what? X squared. So s squared is now what? 4. So what is x? So s will now be plus or minus square root of what? 4. So x is minus square root of plus or minus square root of 4 will give us what? 2. So vertical asymptote is s is equal to 2 or s is equal to what? Minus 2. So now our vertical asymptote is s is equal to minus 2 or s is equal to 2. So it is very simple. Now remember the first question we solved. We saw that our vertical asymptote is minus 2. If I put minus 2 here now, minus 2 raised to power 2 will give me 4 minus 4 0. You see I've gotten 0 under, math error. Now look at this one now. I said that our vertical asymptote is minus 2 and 2. If s becomes minus 2 raised to power 2 will give us 2. Will give us 4 rather. 4 minus 4 will give us 0. Anything over 0, undefined. If our s is 2, 2 raised to power 2 is 4. 4 minus 4 will give us 0. Anything over 0 is undefined. So your vertical asymptote is nothing but those points that make the function to be what? Undefined. Now look at question number 3. Okay, look at question number 3. What we have here is x plus 6 over x squared minus 5x. Is there anything we can factor up? Nothing. Is there anything we can factor down? Down is x squared minus 5s. Okay. Can this one, is there any image this one will produce that can cancel something here? Or is there any image this one will produce that will cancel something here? I don't think so. So even if this is s plus 6, if I factorize this, if I'm factorizing this now, what I'm going to have now will be, this is a s squared minus 5s equal to 0. So s into x minus 5. So s minus 5 cannot cancel s plus 6. So there's nothing to factor at. We are not going to factor at anything. Like we did in the first one, we factored out something. In the second one, we did not factor out anything because it is immaterial. There is nothing to factor out. In the third one, it is also immaterial. There is nothing to factor out. So had it been that this thing now is something like a quadratic function, I'll factor it out. Then factor this one out and check if there are things that can what? Cancel out. So for this one now, I am looking for the possible values of s such that the denominator will be what? 0. I know that whenever the denominator is 0, the function will be what? Undefined. So I will now just say s squared minus 5x is equal to what? 0. So here I can factor out s. This is s squared minus 5x. So I can factor out x into what I have here now will be x minus what? 5 equal to 0. So this means that s is 0 or x minus 5 is equal to 0. So s is 0 or s is equal to, when minus 5 crosses the over, we have what? 5. So our vertical asymptote is s is 0 and s is what? 5. So let us try it. If you carry this 0 now and put here, if s is 0, 0 squared minus 5 times 0, 0, 0, 0 squared minus 0 will give us 0. Anything over 0, undefined. If s is 5, 5 raised to power 2 will give us 25. Now 5 times 5 will give us 25. 25 minus 25 will give you what? 0. So our vertical asymptote is 0 and what? 5. Again, look at this one. Determine the vertical asymptote of this. So this is 5 plus 2s squared. So this particular quadratic function on the up is incomplete. Okay, but look at the one down. The one down is 2 minus s squared minus 2 minus s minus s squared. So I'm going to simplify the 2 minus x squared. So what I'm going to do is that I can use my calculator to factorize this. So if you check now, I can write this thing as minus s squared minus x plus what? 2. Remember, minus s squared minus s plus 2. So which means that my a is minus 1, my b is minus 1, and my c is what? 2. So let me use my calculator and punch it. Let me get the root with my calculator. She mode equation 5, quadratic is 3. My a is minus 1, my b is minus 1, and my c is 2. So my x1 is minus 2, my x2 is 1. So I can still write this as x plus 2, because when this comes over it becomes plus. I can still write this as x minus what? 1. Such a way that if we expand this, we are going to have this. So this thing now, this 5 plus 2x squared over 2 minus x squared can be rewritten as 5 plus 2x squared over x plus 2 and x minus 1. So for the function to be undefined, the denominator is 0. But for the function to be defined, the denominator can never be 0. So I'm looking for the possibility of here to be 0. So for here to be 0, it means that everything under will be equal to 0. So if this thing happens, I have s plus 2 equal to 0, or x minus 1 equal to 0. So when this happens, I have that s is equal to minus 2 or s is equal to what? 1. So the vertical asymptote of this very function is minus 2 or 1. Okay, minus 2 or 1. So look at option A, 1 and 2. So I think this should be minus 2. Maybe I made a mistake while writing. So the answer should be option A. Okay, the answer should be option A. So go to number 5. Look at number 5. Determine the vertical asymptote of f of s is this. F of s is this. So for number 5, what we are simplifying is x squared minus 25 over s cubed minus 6s squared plus 5x. So for the upper one, if you look at it, this is sums of two squares. 25 is 5 raised to the power 2. So this is something as a x plus 5 and x minus what? 5. Sums of two squares over, when you have x squared minus 4. So it's something as s squared minus 2 squared. So you can write it as x plus 2 and x minus 2. So if you have x squared minus 36, 6 raised to the power 2 is 36. So this is s squared minus 6 squared. So you can write it as s plus 6 and x minus 6. So this one is s squared minus 25. 5 raised to the power 2 is 25. So I can write it like this. So the denominator is s cubed minus 6s squared plus 5x. So we have to factorize this to check if anything can cancel out. So don't forget how to punch a cubic equation. I go to mode, I go to equation 5, I go to cubic, which is 4. First of all, what I have is s cubed minus 6s squared plus 5x. So my a is 1, my b is minus 6, my c is 5, and my d is what? 0. Remember, cubic equation is of the form as cubed plus bs squared plus cs plus d equal to what? 0. So punch. My a here is 1, my b is minus 6, my c is 5, then my d is 0. So here I have that x1 is 0, I have that x2 is 5, and I have that x3 is 1. So this is like having something like x into, this one would be x minus 5, then the other one would be what? X minus 1. Okay, no, when 5 comes over, it comes minus 1 comes over. So I can replace this thing with s into x minus 5 and x minus 1. So this will now change to x plus 5, x minus 5 over x into x minus 5, x minus 1. So x minus 5 can cancel x minus 5. What I have now is x plus 5 over x into x minus 1. So we are now looking for the value of s for which the denominator is 0. So for the denominator to be 0, it means x into x minus 1 is equal to what? 0. Don't forget, we are looking for vertical asymptote. So it means that s is equal to 0 or x minus 1 is equal to 0. So s is 0 or x is equal to what? 1. So s is 0 or s is equal to what? 1. S is 0 or s is equal to 1. So the correct option here is option what? D. So again, look at number 6. Determine the vertical asymptote of cot x. So our f of x here is equal to cot x. What is cotangent? Cot is the what? Your cotangent is the inverse of what? Tan. Cotangent is the inverse of tan. And we know that tan itself, tan means sine x over what? Cos x. So cotangent now means inverse of tan. That is 1 over tan. So cotangent means 1 over tan. So if we do 1 over tan s, it will now give us cos s over what? Sin x. So here is a cos x over what? Sin x. So for the function to be undefined, the denominator will be equal to what? 0. For the function to be undefined, the denominator will be equal to what? 0. So for the function to be undefined, sin x will be equal to what? 0. So what is x? X is sine inverse of what? 0. So you can go to a calculator and check for sine inverse of 0. So I change to computer mode. So sine inverse of 0 will give me 0. So sine inverse of 0 means that s is equal to 0. Now 0 degrees is something as 180 degrees. Okay, like if you press sine 180 now, sine 180 will give you 0. If you press sine 0, it will still give you 0. So it means that 0 is the same thing as 180. If you press sine 360, say what you're going to have. To still give you 0. So 0 degrees something as 180 degrees, something as 360 degrees. So the answer to this is 0 degrees, 180 degrees, or this. So when we get here, what we are going to see is 180 degrees. So lastly, determine the vertical asymptote of this. So this one is x minus 2 over what? x squared minus what? 4. So looking at the one below, it is sums of two squares. It is x plus 2 and what? X minus 2. So as you can see, s minus 2 can cancel s minus 2. What we now have now is 1 over what? X plus what? 2. For the function to be undefined, the denominator is equal to 0. So x plus 2 is equal to 0. So s is equal to what? Minus 2. So our vertical asymptote is minus 2. So here, our answer is option what? B. So the concept of vertical asymptote is that you're looking for a function at which, or you're looking for the values of s at which the function is what? Undefined. And for every fraction to be undefined, the denominator will be equal to what? 0. But once you see a fraction, check if the numerator is factorizable, you factorize it. Check if the denominator is factorizable, you factorize it. Then cancel out things. Then you start, equating the denominator to 0 or checking other conditions. Okay, so go through it, use past questions, and settle yourself. Thank you very much for watching.